Okay, this is our third and last podcast on the LeChatelier's principle. And in this podcast, we're going to talk about what happens when I increase or decrease the temperature to a system that's at equilibrium. So when I am looking at a system at equilibrium, and I'm looking at what happens when I add temperature or decrease the temperature, I have to think about whether I have an endothermic or an exothermic reaction. If I look at my delta H here, this is telling me that it's exothermic, so I can write heat as a product. Okay? Likewise, if my delta H is positive, that means it is endothermic, and I write heat as a reactant. And when I do that, then I can think about LeChatelier's principle, just like what happens if I increase the concentration of something. Because what I'm looking at is, what if I increase the product heat, or what if I increase the reactant heat? Okay. So you got to know whether or not your reaction is endothermic or exothermic. So if I have an exothermic reaction, I'm producing heat. So let's say I have A plus B giving me C plus heat. Okay? And if I increase the temperature, I can consider that to be increasing the heat, right? So if I'm increasing the heat, the system shifts left to reduce the heat. So it's reactant favored. Okay? If I lower the temperature, that's like lowering the amount of heat. So I will shift right to increase heat. So it is product favored. Likewise, if I have an endothermic reaction, so let's say I have D plus heat giving me E, okay? And if I increase temperature, it's like increasing a reactant, right? It's going to shift away from that, and it's going to increase the amount of product. It's going to be product favored. Okay? If I decrease the temperature, it wants to get heat back on the left side. It's going to shift left, and I will be reactant favored. Okay, so I can look at it from a particle standpoint. Here I have a system at equilibrium. Heat, in this case, it's exothermic, so I have heat as a product. If I add heat, wants to shift away from the heat, right? Wants to lose heat, so it's going to shift. I'm going to lose some of my methanol, right? I've lost methanol, and I've added additional carbon monoxide and hydrogen. Okay? Here again I have, it's still exothermic, right? I have a system at equilibrium. I cool it off, which means it's losing heat. In order to restore heat, it's going to shift to the right and make more methanol. I can see another methanol produced and carbon monoxide and hydrogen consumed. Okay, so let's look at a couple of examples. Here we have PCl5 decomposing according to the endothermic process. So we're going to put heat on the left as a reactant. Which one of the following includes only changes that will favor decomposition? Decomposition means shift right. Okay, so let's take a look at these one at a time. If I add PCl5, I'm adding concentration here. It's going to want to shift away and move right. That will move me right. Okay? So addition of PCl will do that. What about if I add Cl2? If I add Cl2, it's going to shift me left away from the Cl2 that was added. So addition of Cl2 is not 1, but the removal of Cl2, in order to get it back, it's going to shift right. So removal of Cl2 will. Look at what's going to happen with temperature. So if heat is over here, and I decrease the amount of heat, it is going to shift left, right? So decreasing heat won't work, right? But if I increase heat, it's going to shift away from the heat, shift right. So increasing temperature shifts me right. Okay. And lastly, what's going to happen with volume? So if I decrease volume, I increase pressure. Okay. So here I have 1 mole of reactant gives me 2 moles of product, right? So if I am decreasing volume, increasing pressure, I want to reduce the pressure. In order to do that, I'm going to shift left where I have fewer moles of gas. So that is not going to give me more product. Okay? But increasing volume decreases the pressure. I want to move in the direction that gives me more moles of gas, so I get more pressure. I will shift right. So my answer will be D. Alright. How did the following changes shift the equilibrium of the given reaction? Here I have N2 plus 3H2 gives me 2NH3. So let's get our bearings. We have exothermic, so I'm going to put heat on the right. Okay. I have 4 moles of gas here, 2 moles of gas here. Alright, so if I increase the I'm increasing the amount of product I have of heat. It's going to shift left. So therefore, if I decrease the temperature, if this goes down, it's going to shift right to compensate. Okay, if I increase volume, I decrease pressure. In order to increase pressure, I have to shift left where I have more moles. Likewise, decreasing volume, I'm going to have to shift right where I have less moles. Okay? If I add N2 or H2, I'm adding reactants. I need to shift right to get away from that. If I have NH3, I have excess product. I need to shift left to reduce products. Now, if I remove N2 and H2, it's just like lowering this, right? So I want to get more, so I'm going to shift it back, left. If I remove NH3, I'm going to shift right to get more of it back. If I add argon, nothing happens. Inert gas. Changes the overall pressure, but not the partial pressure. No change in the product to reactants, which is my equilibrium. Alright, last one here. Which of the following changes will result in the reaction shifting toward the formation of more products? Alright, delta H is greater than 0, so heat is on this side. It's endothermic, right? I have 1 mole of reactants, 1.5 moles of product. So if I increase temperature, it will shift right, so that will shift me to products. If I add argon as an inert gas, no effect, right? If I decrease the volume, I increase the pressure, and in order to get more pressure, in order to deal with more pressure, I need to go to lower pressure or to the direction with less moles. Okay? If I add nitrogen, I am increasing my product. I am going to shift left, wrong direction. If I remove O2, I want to get it back, so I'm going to shift right towards product. Okay, hope that helped.